Hey everybody. Sometime back, Ed Snyder, Zipster, proposed that it might be possible to take a TRS-80 MC-10, which I have heavily modified here in front of me, um, and uh, and upgrade it to potentially even a 32K internal memory. So so what I've done at this point, I'm about a third of the way through what I think might be a way to achieve this. um, One of the things that I wanted to do was, not only give this memory access to the CPU, to the 6803, but also to the 6847 VDG. So anyway, so I thought I'd demo that. Please forgive the video quality. I don't have Coco VGA installed in this particular machine that I'm hacking on. So I've just booted it up here, and of the 32K, I can currently see 16K, so that's a good sign. Um, then additionally, I guess what I wanted to see was whether I could get to, well, one, multiple video pages, and two, that the VDG could address full 6K video pages, because that's normally a problem with the MC10 in general anyway. So let's try some things. Poke 49151, comma 1. So for those of you guys who know, this is a region of mapped memory. The entire 8K block, 16K block is actually addresses a single register on the MC10, which controls the video mode and the 1-bit sound. So I'm using the upper end of this region. Normally, bits 0 and 1, the two least significant bits, are unused. However, I've added an additional set of flops to this, so I'm now grabbing the least significant bits. And of these, the lower of the two bits will let me jump the VDG addressing by 8K in memory. So if I do this, now I'm looking at a region in memory that is 8 kilobytes away. Let's type blind, poke 49151, 0, and go back to our standard screen. So looks to me like we have access to two screens. Let's see if we can draw on that other screen. Poke 49151, 1, 20 1.8, 255. Let's do semi-graphics characters, and let's get through them quick. Let's step in arbitrary number 15. 34J equals 24,576. So this is the equivalent of hex 6000. For those of you guys who are familiar with the MC10 memory map, this video screen that we're seeing right now is at hex 4000. I'm interested in changing memory up at hex 6000 to 25087. The screen is 512 bytes in size. Poke J, comma I, next J, next I. And then when we're done with this, so we're not typing blind, let's come back to this screen, 49151, 0. Run. Oh, here we go, we're drawing on the other screen with semi-graphics characters. And then we come back here. Okay, well, let's prove that that was two different screens. So let's take this a little step further. 4D equals 0 to 500. Let's add a delay so we can see what's going on. Poke 49151, 1. So let's go back to that screen, and then let's delay. And then go back up to that poke. Let's alternate back and forth between this screen and the screen that's up 8K from here. So we can just run starting at 70 because we've already updated that screen up at, that's 8K away from us right now. Well, there we go. Now we're switching back and forth between the two video screens. All right. Well, so that's proven that we can get to two different video screens. Let's prove that we can get to all 6K from the VDG. Let's see here. All right. So let's modify this a bit. 24i equals 0 to 255 step 9. I want to write out some bytes here to a graphical screen. Actually, let's also change. Let's use a video, like I said, let's use a video graphics mode, 125. So 125, that will put us in color set 0, graphics mode. That will set the graphics mode to resolution graphics 6. So GM 0, 1, and 2 will be all set. This is the equivalent of P mode 4 on the Coco. And the least significant bit is set, so we can do this in the other screen. Okay. Let's see here. 24, 576, the start of the other graphic screen. But this time we want to go up to 30719, which is 6 kilobytes in size. Okay, I think the poke stays the same, the necks stay the same, and let's delete 80, 90, 100, 110. Okay, all right, so we're going to go into graphics mode on the alternate video page. We're going to walk through memory, writing bytes, and we're just stepping an arbitrary size so that we don't see one pixel appear and then have it count binary. Okay, let's try that. All right, so we're writing zeros. Nothing too exciting yet. Let's give it a minute. Okay, so while we're waiting for this to draw, I guess I'll mention right now this piggyback mod removes the two 2 kilobyte SRAMs that are currently in the system and replaces them with a socket in which I install a 32K SRAM. That's a 62256. It also piggybacks a 74367 for the upper address decode, and a 74174 for giving us an extra couple bits in which to remember those least significant bits of the sound and graphics register. So anyway, looks like it's working. Looks like if this wasn't working correctly, we would actually see this data down here being a mirror of the upper data. So it looks to me like we're getting to all 6K bytes. So anyway, like I said, just a brief status update. Hopefully I'll be able to carry this all the way through and get us to 32K with some maybe some additional extra features as well. Thanks for watching.